Hello and welcome to the channel. In this video, I'm going to show you a very cool website which is called as LLM Sampler. It's a free tool where you can play around with different hyperparameters to see how the output from a large language model works. This is important because all of these hyperparameters like temperature, top K, top P and all this stuff, they really enable you to have a more nuanced and grounded response from large language model. If you are following my channel, you might have seen me testing out various models locally, and then I have to tinker sometimes with some of the hyperparameters to get the response right. And normally I also try to show you how I troubleshoot that and how I tinker with that. So never assume that if you are just going with the default values, the response of the large language model will be optimal. More often than not, you have to tinker with those knobs, which are the hyperparameters, to get the output from the model right or as per your own requirement. And this LLM sampler, which is a free tool, enables you to do just that, to clarify those concepts so that when you're working with your own models, your own prompts, you can apply the same techniques or learning to your own configuration. Before I show you how this works, I believe it is very important to get few of the concepts crystal clear. I'll try to describe those concepts around these hyperparameters and what exactly happens when a model tries to predict the next token, because if you look at the very high level, this is what all of these large language models or this generative AI is trying to do. We give it a question or prompt or input text, and it tries to predict the next word or token. For example, in this example on their website, you see our question is: avocados are rich in monounsaturated fats, which are necessary for brain function, cognitive development, and then there is a blank, and we expect the model to fill in that blank. Now, how does model generate the next word or token? This is a very interesting question, and we need to get it crystal clear before we could understand all of these hyperparameters. So let me show you this very simple example. If you look at this example, let's suppose there is a large language model and we want to ask it a question. He has an idea, and that's it. So we want model to predict the next word after idea. So what happens is we give this input text to the tokenizer. Tokenizer converts this text into tokens, and then you see these are 10, 67, 154. These numbers are the IDs of the tokens. For the simplicity, we have just generated one token ID for one word. So he is 10, has 67, and 154 IDI is 891. And then these tokens are fed into our large language models as an input. What large language model does here, it processes these tokens, and it does a lot of things there. Once it has processed it, it converts it into logits, which logit is a score assigned to every possible token in model's vocabulary. So, and then there is a function which is called as softmax function. That softmax function converts these logits or scores into probabilities. So probability means that model thinks that next word after idea should be that, and there is a 20% probability of that being right. And then the next one is for has 10% probability because has 3% probability. So model has converted these tokens after processing into logits. Logits have been converted into probabilities by softmax function. Now we have multiple options here. How does a model decide that which one to go with? Now first there are two things which are called as decoding strategies. So decoding strategies control how to navigate this distribution of probabilities where we have 20%, 10%, and 3%. So for that we have two popular techniques. One is greedy search, and then second one is beam search. Greedy search is a decoding strategy that selects the most likely next token, and that's it. So in this case, it is just going to go with that and it will ignore rest of the lot. The problem with greedy search is that it is so simple, it doesn't really take into account the relationships and the overall picture. So another option is to go with beam search. Beam search is again a decoding strategy that selects the most likely next token, and not just token but multiple tokens. So in this case, for example, it might go with that and for 20% and 10%, and then it is going to evaluate among these two to go, okay, which one should I go with. So these are the decoding strategies. Now, out of these, how do we select? So there are two very common sampling techniques. One is top K and top P. These are also called as hyperparameters, and they control primarily which one or which token to select. For example, top K, it simply selects the top K tokens with the highest probabilities. So if you set top K to 1, for example, your beam search has result that and for. You set top K to 1, it is just going to select one of them. That top P, which is also called as nucleus sampling, instead of selecting only whatever you randomly selecting the token, it selects the smallest set of tokens whose cumulative probability exceeds a certain number P, which you set. For example, you say 30%, the model will select the tokens until their cumulative probability reaches 30%. So these are different techniques where the next token is selected, and that is where this LLM sampling tool can become quite handy. For example, we are saying avocados are this, and then how do we do that? You just select, for example, check that you know checkbox here in the temperature, and you see it has selected that, okay, absorption has a probability of 24% being the next word, and then it goes on and on and on. For example, you say, no, I'm just going to go with top K here. Let me also make it smaller so that you would be able to see it. Okay, that's better. So I'm just going to select top K, and right now it is showing me 50 results. Top 50 results, you see. So instead of showing top 50, I just say, okay, I just want one result. You see, absorption has only one. I say, no, give me three. There you go. We have three results now. Top three, I don't want to worry about next of them. You say, okay, I also want to go with nucleus sampling. It is one. You just go with two. Maybe two here, and I just unselect this one. So nucleus sampling has given us this, that okay, these are the ones which as a cumulative one reaches to this one, then model is going to select out of these. And then we have this something called as min underscore p. This one, I'll just select it, and this basically selects a token with something, uh, minimum, which meets the minimum probability threshold for a token. So maybe I'll just say, okay, this two, only this one meets up one, and then I just say, okay, zero point 0.5. So these are the ones which meet the minimum probability threshold. If you take, maybe lower it more, there will be more results. So you can just select how much um, deterministic or creative the model gets. And then there are few others which are not really that important, like top A. If you scroll or hover over it, it just keeps the token with probability greater than this formula. Same goes with tail freeze Z. This is its cutoff tokens after the cumulative frequency. And then we have typical P, which is primarily, in this one the model is encouraged to produce more common tokens, adjusting the probabilities accordingly. So you just select it, you say okay, 0.2, and then it has just gone down. And then, and of course you have to tinker with it. Maybe you will just remove this, and then just use zero point 0.2. It will just go with the these most common tokens, maintenance and prevention. You say, okay, I just want more common token, you just increase it. You just select it to 1. These are all the more common tokens. So you see, as long as you understand what these hyperparameters do, you can tinker with these values, and then you can make sure that whatever your model is returning is according to your requirements. For example, your requirement is to write a creative story. For that, you would have to make it as creative possible. You have to increase a pool of probability so that model will have larger pool of probable tokens. But if you're writing some very medical or legal document where you just wanted to stick to what it is, then maybe you'll just decrease that creativity. Or maybe for coding you will decrease it. Maybe for something like mathematics you will decrease it, because you don't want to get creative while coding it. So this is how you can play around with it. I hope that this was interesting, and especially I would suggest that before you play around with it, just look at this to understand how exactly the model predicts the next token and what exactly these decoding strategies and these hyperparameters are. So that's it, guys. I hope that it was useful. If you like the content, do me a favor and share it among your network. If you're already subscribed, please just share it on social media among your network, as that helps a lot. Thanks for watching.